Good afternoon and Tajahu to all the distinguished guests here. And it's a great honor to be here, and I thank the organizers and also the co-organizers of this conference, allowing us to be a part of this and choosing us to be a keynote speaker. I think the past 3 days, I think it has been very informative to us, especially, and I was quite well aware of the CSP and STEM technologies, and I wish all the CSP projects in China good luck and a great success. So before I start my presentation, I would like to just briefly introduce about our company. My name is Rajesh, and I work as Director of Sales and Marketing for Seal Valves Private Limited. We are a family-owned company, and we have been manufacturing quality and reliable Seal valves for the past 25 years. And we have been supplying to various industries related to oil and gas, petrochemicals, and also the concentrated solar power plants. Now, I would like to briefly tell that our annual production capacity is close to 50,000 valves per year, and we can proudly say that we are one of the greatest, the largest manufacturer of Seal valves in the world. So the topic of today's discussion is Seal valves and the ideal and the right choice for heat transfer fluids, steam, and piping systems. So my brief presentation will cover the gland leaks that happens in the industrial plants, and the various industrial norms and regulations that's been covered by the environmentalists recently, and why to choose a Seal valve. And I would like to justify why a Seal valve is used for thermic fluids, molten salts, and the steam applications. And I'd like to show you different types of valves that have been used by the industry. And I would like to show you some pictures which shows our manufacturing capability, and a quick reference of the supplies that we have made to CSP industry. And I would like to have a conclusion statement. So as you can see here, these are the gland leaks that happens in industrial plants. As you see on the top left slide, you see a media loss. That's basically a steam loss that you visibly see always in the industry. And on the other side, you see a vapor cloud, which happens over a period of time, and it self-ignites or due to a spark, there's a fire always hovering around. And you can see there in the other slide where you see that there's a HTF leak which happens, and always this raises the health safety issues in the plant. And apart from that, any HTF leakage can always be a cause of insulation damage. So what are the environmental norms and regulations that try to cover up to minimize the gland emissions? So we talk about the optimizing the plant energy consumption by avoiding media losses and top-up cost, maximizing plant operating efficiency, reducing maintenance costs and LDA costs, keeping employees and neighbors safe, and lessening the facilities' environmental impact and complying with increasingly stringent air quality regulations. So when we talk about all this, I think we're talking towards reducing the fugitive emissions from the piping system and also the associated equipment. So when we talk about fugitive emissions, fugitive emission is a term that's been used widely in the industry, which talks about the leaks that happens, from the pipeline equipment and the heat exchanger systems, and definitely covers valves. I would like to show you some video which gives you an idea about the type of leakages that we're talking about. So this is something, a leak that you actually visibly see whenever you are going around the plant, and definitely this is a loss. This is a media loss, and definitely when you have a media loss, I think you lose money also. And the other type of leakage which you frequently see, which is not visible to the human eye, I think this is where a lot of concentration has been put on by the environmentalists. As you see initially with a visible eye, you don't see the leakages. But as you see through a scan through an infrared camera, I think you see the leakage that's been happening, and this has been a great concern to all the environmentalists, because there are always there is a leak of vapors that's actually been emitted to the atmosphere, and this is adding a lot of greenhouse gases to the atmosphere, and actually reducing and increasing reducing the Earth's environment. So if you look at the main causes, that happens, from the valve, as you see here. So I just briefed a graph here. I just put in a graph here which shows you the valve fugitive emission sources, which basically happens, from the conventional gland. As you see here, the stem being the dynamic seal, the dynamic stem seal, it always the stem always operates. So you see that there is always a leakage that happens due to the dynamic seal arrangement. So the main reasons, for the gland leakage has been due to the improper stuffing box design. And then you have a mass loss of graphite packing over a period of time. Then you have the piping vibrations, that happens. And outside environment, especially a salty environment, damages the stem area, and that's been a main cause, for the gland leakage. And you have a very poor stem finish that contributes to the gland leakage, and also the stem redistribution. So, is there any solution to this? Because you often see that there is always a gland leakage that happens around in the industrial plant, and people do accept that these gland leaks are quite normal. But as I do say that there is a valve which can offer you the different advantages and reduce the fugitive emission and also the losses from the gland area. Just use a bellow seal valve, and the main feature of a bellow seal valve, as you can see here, you have a metallic bellow that acts as a primary stem seal, and that is welded basically between the plug and the bonnet area, and that ensures that there is absolutely zero leakage into the atmosphere. So this is one of the main, I can say, the main feature of a bellow seal valve. So when we do design a bellow seal valve, we ensure that we design the valve bodies accordingly, also to meet the cyclic life as per MSSP 117. So coming to the advantages, what I can tell you about is, like, you have a gland leakage that can be reduced to 10 to the power of -7, 10 to the power of -8 millibar liters per second. We talk about a class A and a vacuum type valves. And when we talk about these gland leakages reduction, we talk about the leakage being around 0.003 liters per year. That's actually reducing a lot of emissions to the atmosphere. So by doing this, what you get, there's no medium loss to the atmosphere, and at the same time you don't have any air ingress into the piping systems. So apart from that, it protects the environment, it brings in a high safety, and it prevents the stem corrosion. And when you do all this, I think you have a quick payback period, because definitely initially the cost of a bellow seal valve is quite high. But I think over a period of time, I think this valve will pay you back because of all the advantages you see: no replacement cost, no equipment downtime, no maintenance costs, and no spares. And when I do mention in my previous slide, we talk about the gland leakage being reduced to 10 to the power of -7 and 10 to the power of -8. This requires a certification, and we do have done a certification through the fugitive emission certificate that was conducted through TUV, and we went through a rigorous testing program in one of the renowned laboratories in India, where we did a thermal cyclic test for 1,500 cycles, and you can see there we achieved the leakages close to 2 to the power of -2 into 2.5 into the power of -7 on a regular basis. So what we did in this test is basically, as you can see here, the valve is subjected to rigorous testing. We do test the valves at a normal temperature, at high pressure of 137 degrees centigrade, and then we do test the valves at high temperature at a pressure of 93 bar. So you can see this, the valve is subjected to rigorous testing procedures, and then the gland leakages are tested. So this definitely shows that, that the bellow seal valves do confirm to zero emissions. This is the compliance that we can do. And you can see in my slide as been presented here, we use a test medium as helium. And overall test duration took us 3 to 4 days, and we did no stem seal alignment. In this process of testing, we didn't adjust any stem seal. So that shows that the reliability of these valves is too high with respect to zero gland leakage. just a slide which I want to show to you about the economics of using a velocity valve versus a conventional gland valve. As you can see, because this is actually the test we carried out, we did fluid emission studies, the plants in India, and we did the study wherein you can see here a normal gland valve. Initially the purchasing acquisition cost I think is quite too low, but over a period of 3 years, as you can see, the gland valve will be expensive by 5 times. So the velocity valve still remains to be around 30% more than initial procurement cost. So this actually shows that that velocity valves is quite cheap when you look at long-term acquisition cost of a valve. And the reasons why the gland seal valves were quite expensive is because of all this. Because we had energy loss to the atmosphere, you had pipeline vibrations that affected the performance of the piping. You had the commissioning space that you had to store with it, as a part of the replacement program. Then you actually had to monitor the valves regularly, because you need every industry will go through a LDR program, that's leak detection and repair programs, wherein you actually have to spend a lot of money. And apart from that, you also have to face penalties for non-compliance. So all this adds a cost to the conventional valve, as I shown in my previous slide, and that's why it becomes more expensive. Hence, I think what I can say is velocity valves do work out better when you look at long-term acquisition costs. And do I only say that velocity valves are good? No, I don't think so, because even you talk about Eastman, the solution who provides, who is actually the supplier for HTA fluids, he do recommends that it's better that you use a velocity valve, and virtually it gives you a leak-free operation. And this is a brief layout of the CSP layout, which I just showed you, and you can see there, you can see the population of, you can just show the applications of a velocity valve on the HTF piping, which involves the header piping, the solar field header piping, and also the drain and vent piping in the systems. So if you look at the operating cost that happens in the CSP plant, it's just to give an example about the consumption of the velocity valve and also the cost involved. As you see here, the HTF system overall costs about $70 million, and when it comes to valves, we do invest about, the customer invests about close to $750,000, and normally the estimation top-up cost on HTF fluids will be around 5 to 7%, assuming that the valves will be used as velocity. Why velocity valves for thermic fluids? Because most of the HTF that's been used in the CSP plant is a thermic fluid as the main collector of the solar heat. So as you see, the normal operating pressures of a thermic fluid is around 16 to 20 bar, and the temperature is close to 393 degrees centigrade. So when you look at the HTF applications, especially the thermic fluid, we talk about what does the end user look at. He basically looks at a good quality, zero gland leakage, reliable long life, no air ingress into the systems, because if you have air into the HTF system, it normally leads to carburization. So I think you need to have, customer normally prefers to have no carburization of HTF in the pipelines. And when you have zero leakage, definitely go towards no fire hazard situation. So this is one of the requirements of the HTF end user. So, and you need to maintain a constant temperature gradient in the pipelines, clean piping systems, and you need to have a highest human safety and less dose of nitrogen gas, because nitrogen is quite well used for blanketing in HTF systems, and less top-up costs due to the vapor process. So if you look at all these requirements of a HTF end user, so ultimately you find the answers by using a velocity valve, where you find velocity valve is always at an advantage to use over a conventional valve. The same thing happens with the molten salt, as you can see here. The molten salt again, you need to ensure that there is no gland leakage in the system, because any gland leakage that happens in the molten salt, I think it tends to jam the stem. So because salt freezes on the stem area and it tends to jam the stem. So basically what client is looking at is to have no air ingress into the system and no gland leakage. And this is something that's being done by a velocity valve, which actually ensures that this is a favorable valve on the velocity motor sort of application. So why velocity valves for steam? Again, if you look at what a stem user looks at, again he looks at no steam loss, and stem corrosion has to be prevented, better energy management, less heat loss, increasing efficiency by ensuring vacuuming condenser systems, steam turbine outlet area, and avoid monitoring of valves as much as possible on gland leakages. If you look at all these requirements of a stem user looks at, I think you look at a velocity valve, it always gives you a better advantage economically versus a normal gland pipe valve. This is just to give a consumption of the velocity gauge and globe valves in the 50 megawatt consumption solar power plants. As you can see here, for the thermic fluid systems which operate either on VPU1 or Dawatherm A, you see close to 1,000 valves are supplied to most of the HTF systems, and for the modern source systems, we closely supply close to 400 valves. And again, if you look at the material of construction here, for the thermic fluids, we do give in carbon steel with a trim egg connection and developed in SS32 and 363 Ti. And for the molten salt, which operates at 565 degrees centigrade, we do offer the material in 321H and 347H with belows in 625. So these are some of the types of valves which are widely used in the solar power plant. This is a velocity white globe valve, wherein you can see that the neck of the body is angled out at 45 degrees or 60 degrees. So basically, by doing this, we are trying to ensure that the flow path is made as much as possible in a straight line. So if you look at the basic constructions of a velocity valve, you can see here it has a specially designed bodies, wherein the neck lengths are much higher than the normal valves. We do hard facing of the stelliting on the seating surfaces. We have an integral body seat, and we have used the multiplying bellows. Basically, it depends upon the pressure and temperature, and we design what type of bellows to be used. And the body and body joint would be of a tongue and groove arrangement, so that there is no gasket slip, and ensure that there is a long service life. And most of the times, the body body joint, would reduce with the emissions are close to 1 ppm or less than that. And apart from that, we do have a tertiary secondary gland sealing through a packing of thermic light for high temperatures of modern solar. The sizes we cover is from 1/2 inch to 12 inches with a class rating of 300, which is quite commonly used in CSP. And the designs are as per ASME 16.34, and we do comply cyclic life bellows as per MSSP 117. So this is the velocity globe valve rhythm design, which is quite often used in the drain, deep drain and vent connections in the HTF systems. You look at it, this is a fully welded valve, wherein again you have an integral body seat, and cyclic life, again we meet as per MSSP 117. The sizes we manufacture is from 1/2 inch to 2 inches, with class rating of 800 and 300 class. Design basis being EN 15761. This is a bolted design. As you see here in the previous slide, this is actually a welded design valve, and if the customer requests for a bolted design, we can do offer this. And the basic features will be the same as I discussed, as I mentioned before. And this is a velocity globe valve in the cast version, wherein we produce items wherein we manufacture from 2 inches to 20 inches, and the class rating being from class 300 to 600 classes, and the design being as per ASME 16.34, and we designed the valves again as per MSSP 117. This is a velocity gate valve, and these valves are basically used in the pump isolation applications. Again, you see the sizes we manufacture are from 2 inches to 24 inches, and class rating being 300 and 600 class. We manufacture valves as per API 600 and below. We design as per MSSP 7. Apart from this, for the globe valves, we do offer with different designs to meet the isolation or to meet the control requirements of the customer. So we do have the plugs being designed as per parabolic curve or as per linear curve. And for 6 inches and above, we do manufacture valves with the pressure relief system, which is called as a balance plug design. The special features that we can offer with the valves is with gear operator, with actuator operations, with the leakated port wherever required, and we do have optional valve we offer with bypass arrangement, wherein it requires a thermal balancing. We can offer these valves with special features. These are some features that we want to show to you. This is about the velocity gate valves which we supply to a solar power plant in Spain. This is one of the recent executed projects for Saudi Arabia for the Dubai integrated solar combined cycle, where we supplied close to 1,000 valves. This is one of the features that we have, this velocity gauge valve, where we manufactured with the bypass arrangement. Here the customer was requesting for a thermal balancing to operate the valve. This is a 20-inch valve that we manufactured. Again, for the recent Dubai project, we are manufacturing about 3 numbers, 20-inch valves. These are 10-inch and 14-inch valves which we are supplying for rotating and benzene applications to refineries. These are with actuators. And we do the three-way diverter valves for the thermal fluid applications. And just to give you a short, brief idea about our reference list of velocity valves that we supplied to the CSP industry. As you can see here, I think we have been quite well accepted as a quality and a reliable manufacturer for velocity valves over the years. And as of date, I think we have supplied close to 40,000 valves to various CSP plants around the world, which includes Spain, Morocco, US, Nigeria. Recently, we supplied a lot of valves to Saudi Arabia. So just to conclude what I have been telling you, velocity valves actually are becoming a very important product, which is quite, I can say, well accepted by the environmentalists, because I think these valves reduce the emission and have been contributing to Go Green campaign to the various industries. So what I just to conclude, as I can say, is no vapor cloud and hence fire safety is assured with these valves. Due to less vapor losses, startup costs will be reduced. Being vacuum tight, oxidation of HTF is prevented and hence temperature losses are minimized in HTF systems. Long life reliability assured on stem sealing, which is ideal for HTF systems, which look at shutdown over a period of 5 years. And we contribute to Go Green campaign initiatives as a part of renewable energy source program. And I conclude this presentation. If there's any questions, I think it's welcome.
Thank you very much for your speech. Thank you. So if there's any questions, yeah. Please put up your hand. Yeah.
你好，非常感谢那个分享。我想提一个问题，就是关于咱们那个现在塔式的这个光热电厂里面这个熔岩系统里面，用这个波纹管阀是怎么实现这个波纹管不破损？因为在那个塔式的这个熔岩系统，它的温度会比较高，可能会有一些细小的，可能会有一些蒸发，然后可能会在波纹管里面会有一些结晶。长期积累的话，可能会让波纹管会产生腐蚀啊，或者是破损这种情况。我不知道你们有没有碰到。
Can you repeat the question, please?
His question is that in a tower power plant, and because you have this bellows, and when there's high temperature, how do you prevent for the breakage?
Okay, as I mentioned in my slide.
Can you speak a little bit louder? Sorry.
As I mentioned in my slide, which was related to molten salt, you see that I think I mentioned about the bill of material being Inconel 625. Okay, that actually is a very critical part, in a bill of steel. So Inconel 625 meets the temperature requirements for molten salt, which is normally around 560 degrees centigrade. I don't see any issue where the bill of steel gets damaged at high temperatures.
How many degrees? 625? 600 degrees?
No, Inconel 625 goes up to 800 degrees centigrade.
Okay. 他说他回答你的问题是，就是刚刚他在他的 PPT 里面已经提到了，在熔岩这方面使用的话，这个他用的是镍基合金的625的材料，这个材料的话可以就是做到800度也没有任何问题，所以说不会有这种的破损。就是它里面那个波管用的是镍基合金的625型号。
可能只是考虑到就是说有这个熔岩会有这个蒸发之后在波纹罐里面会有结晶，这个有可能会产生破损，并不是说只是因为温度的问题，温度肯定不会有问题。
是有一段会有蒸发，
就是因为你温度高了之后，它那个你首先熔岩液化嘛，液化之后肯定会有蒸发嘛。温度高了会蒸发。
Temperature gets high, there's a steam, so this will might cause the.
Correct. Actually, that's the reason I have actually recommended normally all the end users do use a white tank globe valve. So what happens is there is actually a velocity. I can say there's a minimum velocity that actually carries forward in the pipeline, which is close to about 4 to 5 meters per second in a pipeline. I think that ensures that, there's always the deposition of the molten salt is carried away with the fluid. So you don't see any deposition of the molten salt on the bellows.
So you mean that you have a flow meter that measures?
No, because you see, we are normally the recommendation is to go for a white tank globe valve, so which actually almost follows the path of a straight line. So hence it ensures that there is no deposition on the bellows.
Sorry, this I can't. It's very technical.
Yeah, in my case, it's not about the piper, but just the bellows. Because molten salt will vapor and it will up to the bellow, and I want to know how do you to prevent this to happen.
See, definitely as you look at molten salt, there is always a chance that it can freeze at some point of time. I think that's why I think normally you do have the tracing systems, the heating tracing systems that do take care of this design, of this problem. So there's always an element of deposition that you tend to have, but that's always prevented through the tracing systems, heat tracing systems.
Okay, thank you.
那个如果要是没有听清楚或者可以下去的话，可以再继续去沟通，好吧？您问的这个问题还是非常专业的。大家还有什么其他问题吗？ Okay, I guess no more questions. Thank you very much for the excellent presentation.